Okay, so we keep going with our types of data. Now we are looking at quantitative data. Now, quantitative data, what is it? A quantity, so when we say something is a quantity, that means we can quantify it. We can give it a numerical value. We can give it a number, a size for that represents its amount, its size, right? Or magnitude. So when we say we are dealing with quantitative data, we are dealing with numbers, types of values that have numbers. It's not like colors. We saw that colors have names: red, green, orange, blue. Those are the types of colors. But when we're dealing with the type of data that has values like the mass, like the length, like the height, okay, like the shoe size, then here we are dealing with quantitative, okay, quantitative data, like the volume of water in a thing. Those take numbers, they don't take words. So quantitative data is one that is numeric. Now there are two types: discrete and continuous. Okay, so quantitative in itself has two subtypes, okay? And that is discrete and continuous. When we say we have discrete, we're saying we have a type of value. Is remember, it's a number, it's a numeric value, but this numeric value only takes exact values. Okay, that means most of the values will be whole numbers. Sometimes it could have a comma 5, but there'll be either a comma 5 or a whole number or something like that. It doesn't take any value in a range. No, it takes only exact values. For example, the number of trees in a garden. Okay, we can have them as 7 or 8 or 9. We can't have 7.2567931 trees. No, we can't. So that is discrete. Discrete, those things that take exact values. Another thing is, what you should know about discrete data is that this type of data, discrete, things that take exact values, they arise from counting. That's where they often arise from. When we are dealing with discrete, most of the things would be from counting. Number of cars that pass a place in an hour. Number of goals scored in a football match. Number of things, we have counted them. Okay, even the age of a person, we have counted it. So these things are things that we count. So here is an example, and there's something I want you to know about both discrete and continuous whilst we're looking at this quantitative data, because what we want to learn is how to make the frequency distribution, which we say it is a table. It's a table that summarizes things for us. Okay, so let's go ahead, or organizes rather. So here's an example. The ages of 15 kids in a classroom are as follows. So here we have the ages of 15 kids, the ages. Okay, remember that age is a type of quantitative data. And since it can take only whole numbers, then it is discrete. Let's see how we make this table. So here are the ages of 15 kids. 16, 15, 15, 17, 16, 16, 16, 15, 17, 17, 15, 15, 16, 16, 16. Now, here it says draw a vertical line graph to illustrate the data. Great. So now when we are drawing a vertical line graph, before we can be able to display, okay, or visualize, we can't visualize before we organize. So the moment we get data that is all over the place, this is what we call raw data. We have to organize it by putting it in a table. So the first thing we're going to do is to put it in a table. And that table is called frequency distribution. It shows the values and their frequencies, or the how much. So let's go ahead. So I'm going to say here age, and then I'm going to say frequency. Okay, I'm going to make my frequency distribution. Let's go. Age, then remember, its frequency distribution is just a table which shows the values and the frequencies. Probability distribution is a table which shows all the possible values and their probabilities. Okay, so great. Now here is age, and then we have the frequency. So age, we have 15-year-olds, we have 16-year-old, and then we have 17-year-old kids. So 17. There we go. That's it. We are done. So 15, 16, and 17. Now let's count. How many 15s do we have? We slice them. 1, 2, 3, 4, 5. Is there 15 I haven't sliced? No, 5. So 5 of them. Now let's slice the 16s. 1, 2, 3, 4, 5, 6, 7. 7 of them. Now let's slice the 17s. 1, 2, and 3. So 17 is 3. So now I can find the total, okay? But I don't need it for what they want. They want a vertical line graph. So vertical line graph is like a bar chart, but only that it doesn't have bars, it has lines. So now let's go ahead and let's put one. So I'm going to say now, I'm going to put it here. Sorry for lack of space. I'm going to do this, then I do that. Okay, then I'm going to push my diagram up a little bit. Like this. And then I'm going to put my data. So here I'm going to say, in here, I say age, okay? And my age could be 15 or 16 or 17. Then here I'm going to have frequency, okay? I'm going to say frequency here. Now, what is the frequency? I can see that it was 5, 7, and 3, so it's not much. So I can say 1, 2, 3, 4, 5, 6, and 7. I need you to see. So what was important for you all to see was this table. How simple it is. Look at how simple it is. The frequency distribution for discrete data. So that's why I put this heading, frequency distribution for discrete data. You saw the table? Yes. Why did we need it? Because for us to be able to do the diagram, we need the table. So now we can go ahead. How many do we have for 15? 5. So we just draw a line that goes all the way up to 5. Okay, it should be straight. So I'm going to do this for 15. Then for 16, slanted too much. Should do this. Then for 16, it goes up to 7. So I go all the way to 7. Okay. Then 17 goes up to 3. So I just go to 3 and I stop. So this is what we call your vertical line graph. Okay. Remember that for our discrete, we had vertical line graphs and we also had stem and leaf diagrams. So we'll see them. Now, but this is a vertical line graph. We've seen the frequency distribution for discrete data. What is frequency distribution? It's a table that shows you the values and their frequencies, okay? Which is the how much. Now, when you see things like this, when you have your frequency distribution table, when you have your graph, you can easily see something called the mode. Okay, the mode is a very special type of average. Okay, because for average, we have mean, median, and mode. Types of average. These are values that show, we call them measures of central tendency. Remember, they give you an idea of what your data is like. Now, mode tells you the most popular value. Okay, so for example, if you're dealing with this one where we are dealing with ages, you can easily see which age is the most popular in the class, which is the typical age of students in that class. So you can say, oh, Form 4s are typically 16-year-olds because we have 7 16-year-olds, okay? So most of them would be 16, okay? Just a few would be 15, yet to 10, 16, and then some would be 17, okay? So, but most will be 16. That's what mode helps you to see. It helps you to see the most popular value, right? So in this case, well, we can see that mode is going to be, when we look at mode, we see which value has the highest frequency. We don't put the value of frequency. Frequency is not your data. It's just the how much. But we need to see the data that has the highest frequency. And that is age 16. So when we are saying what is the most common value, we are not asking for the frequency, we are asking for the data. So here our mode is 16 years. Okay, mode is 16 years. This is the mode, most popular value, right? Exactly. Now, sometimes you could have data that has two modes. We call that bimodal, okay? Where you have two values being 17. Let's say 18, we had 7 18-year-olds again. Let's say we had 7. That means we'd have two modes. So we can say our mode is 16 and 18 years, right? Exactly. That will be what we call bimodal, something that has two modes. But if it has more than that, then we find it irrelevant, okay? And that is okay. So mode is just a value which has the highest frequency, or it occurs the most number of times. And that's all you got to know for now. See you in the next video, where we now look at continuous data and see how we make the frequency distribution for continuous, which is the other type of quantitative data.